The following laws obtained from the first 5 laws. We will use all of them to evaluate the following limits in example number 2. So for part A, we will use law number 1 to separate the 2x squared, 3x, and the 4. Next step, I pay attention to the number 2 and 3. So we have the laws before, which is number 3. We can move the c, the constant c, in front of the limit. So we have 2 limit of x approach to 5 of 2x squared minus 3 limit x approach to 5 of x plus limits for x approach to 5. So for the x squared, now we have the exponential. If we have the x to the n power, we just go ahead and plug a in the x location. If we just have x, we use law number 8. We just simply plug a into the x. And what if we have a constant? Then the answer will be just the constant. It doesn't matter the x approach to a. We don't do anything with that a. So we will apply 7, 8, and 9 in the next step. So we will just go ahead and plug in 5 squared and 3 limit of 5. That means it's equal to 5 when you plug in the x, and plus 4. Then we simplify this expression, we get 39. Similarly, we have the quotient, so we will use law number 5 to separate. So we have the limit when x approaches to negative 2 of x cubed plus 2x squared minus 1 divided by limit x approaches to negative 2 of 5 minus 3x. And if you just look at the top, so this is very similar to example A. In the bottom is also similarly like example A. So we just go ahead and plug in the negative 2. We don't have to separate them or show step by step because we already did that in example A. So we just simply plug in the negative 2 into the function. And simplify this expression, we will get 1 over negative 11. So we have the direct substitution property from example A and example B in example 2. If f is a polynomial or a rational function, so polynomial just like example 2a, and rational function just like example 2b, and a is in the domain of the function f. So 5 is in the domain of input a, and negative 2 is still in the domain of the rational function. Then to find the limit, what all we need to do is just plug in the number into the function. To do more practice, we will do example number 3. Find the limit of x approach to 1 of x squared minus 1 divided by x minus 1. You notice that if we just go ahead and plug 1 into the x, then we will get undefined. So first of all, we better do simplify. On the top, we will get x minus 1, x plus 1. In the bottom, we have x minus 1. And then you cancel. So we will get limit of x plus 1 divided by 1, which is just x plus 1 when x approaches to 1. So what happened is that we have the rational function before, and we simplify and we get x plus 1. how do we call this and this? They are the same, right? So they are the same. Okay, because from x squared minus 1 divided by x minus 1, we make x plus 1. So these two functions are the same. So this is a polynomial, so we can just plug in 1 into the function. So we get the answer 2 for the limit. Now we have the result is that if we consider the x squared minus 1 divided by x minus 1 is the function f of x, and x plus 1 is the function g of x. The function f of x and the function g of x are the same when they are defined when x is not equal to 1. Then the limit will be the same. The limit of the function f and the function g when x approaches to a is the same, and provide the limits exit.